Hi, welcome to the next session of Turris Academy. If you already joined us before, you know how it works. We are streaming on YouTube, we are going live, and if you have any questions, you can join us at slido.com/Turris and ask the questions during the stream, and we will take a look at them afterwards, after we finish this session. And we really appreciate feedback that you give us. And this session is actually based on the feedback that we received. Because if you take a look at older sessions, you see that one of the first ones was about setting up a VPN on your Turris router. And feedback that we received was that we got a few questions. One was how to set up site-to-site VPN, not just some remote client that is moving around the world. And other popular question was how to set up WireGuard. WireGuard is a new cool technology, how to set up VPN. And because it felt right, we decided to merge those two questions into one session and show you how to set up site-to-site VPN using WireGuard. And what we are trying to solve and what are the advantages and why we choose WireGuard for this particular setup, and what we will need in this setup will be actually part of the session, and it's in pre-recorded video where I will talk about all the details and show you some pictures to illustrate the problem. Today we are trying to solve how to connect two distinct sites and make services available at each of them available to everybody in both networks. To do that, we will of course use some VPN. If you watched previous sessions of Turris Academy, you probably know that we already covered some VPN setup. Back then I was comparing WireGuard, IPsec and Openvpn, and back then we decided to go for Openvpn because although it has a complex server setup, client setup is really easy and you can set it up anywhere. But back then we were trying to solve the problem that you need to connect over the internet to your home network or your work network. Today we are going to connect two separate networks, which requires much more effort, much more knowledge, and we also care much more about throughput. And it has to be done by somebody who knows at least basics of networking to make it work or to debug it when it doesn't. So in this case we have somebody who is more skilled than the user in our previous example. So we don't need as simple setup as back then, and we can leverage all the advantages of WireGuard now. So what would we need to set up site-to-site VPN using WireGuard? Of course, the first requirement would be router that supports WireGuard, like Turris Omnia. Then we will need different IP segments everywhere, and regarding everywhere, I will come to that later on, because we have plenty of IP subnets that we need to cover. Next, we will need at least one public IP address. If we have public IP addresses on all sites, it is an advantage. If we don't, we can do with at least one. And we need you, skilled IT guy who understands basics of networking and is not afraid of using CLI and Lucy interface. As setting up a site-to-site VPN and WireGuard is not as trivial as Openvpn, we don't have any module in our voice interface, so we will be using either CLI or OpenWRT's Lucy interface. So this was some generic introduction into why we chose WireGuard, and little warning that it wouldn't be as easy as Openvpn we did before. One thing that I skipped through really briefly here was the problems with different subnets everywhere. And in the next video, we will take a look into what subnets we actually have and what potential conflicts can occur there. There's plenty of subnets that we have. On site A, we have some local network that has its own IP subnet. On site B, we have different network that also has some IP subnet. To interconnect them, they both need to be somehow connected to the internet, and they might have different ISPs. So those ISPs will also have some subnets that they will use to connect both sides to the internet. And apart from that, we have the WireGuard tunnel that we will use to connect site A to site B. So in total, we have 5 different subnets, and we need to make sure that all of them are distinct. Let's take a look at example how it could work in IPv4. We have ISPs on both sides that are providing us with public IP addresses. We have one large site, site A, that is using 10/8 network for addressing local computers. And we have a smaller branch of it that is using 192.168.13/24 subnet. Those can be easily interconnected. For the WireGuard connection, we use often forgotten 172.16 subnet, and we will use subnet 42/24, as you see on the picture. Now, this is the situation where it will work, but where we can face some troubles. For example, if we have small branch office connected via ISP that doesn't offer public IP addresses, we might end up with 10/8 on ISP side or 172.16 on ISP side. That one would be actually pretty good, because then we could just pick different IP addresses for our upcoming WireGuard tunnel. But with 10/8, it will be much harder to overcome. Another potential problem is if we are joining, for example, 2 companies or 2 private homes, then there is a high chance that companies will have 10/8 in their internal networks that we are now trying to connect together. Or if we are joining 2 private homes, there is high chance that there will be 192.168.1/24 on both sides. So in those cases, when we have a clash, we need to change the IP range on one side. If we use IPv6, everything becomes much easier, because our ISPs will probably offer us public IP address by default. So all those ISP IP addresses will be from 2002/16, and both our sites that we want to interconnect will have randomly generated ULA addresses, so they wouldn't clash. And for WireGuard tunnel, we can simply use link local addresses and it will work. So there's a high chance that we wouldn't need to deal with any of those troubles if we use IPv6. This also brings me to a hint that might be handy to you. If you are connecting to legacy networks and it is hard to change their IP addresses, the simplest solution might be to move them to IPv6, and for transition period provide NAT64 and DNS64, and use IPv6 to connect to all those services. But that is something out of scope of today's session. So that was a little bit of theory regarding how we will do the setup and what potential problems we can run into. Hopefully it didn't scare you that much. I would like to remind you that we have option for you to ask questions on Slido. If you are watching and something is not clear for you right now, write it down so you wouldn't forget by the end of the video. And now we will go to the last part and do the actual setup. As I warned you before, we don't have any nice integration, so it will be a combination of Lucy and we will touch even CLI. So get ready for that. Let's take a look at how to set it up. As I said previously, we don't have any integration in our voice interface, so we will be using Lucy. And for one part, we will be also using CLI. One thing that is specific about WireGuard is that all the peers are equal. So there is no difference between setting up various routers. So I will just set up one, and you can set up the other routers in the same way. So let's go to the web interface. As I said, we will be using Lucy interface, and I will make everything a little bit bigger to be better readable. Now let's log in. First thing that we need to do is to install the software. We go to System, Software, and if you have this list empty, you might need to update lists first. Now we can start to search for the WireGuard. We can see various packages like WireGuard tools, kernel module for WireGuard, and we can also see Lucy Up WireGuard, which sounds like a nice thing to have. So let's start by installing the Lucy Up WireGuard. Now we see that as dependencies, we pull in WireGuard tools that we needed anyway. We will pull in kernel module for WireGuard. That's also a good thing to have. And one of the important packages as well is Lucy Proto WireGuard, which is actual support for WireGuard in Lucy. Let's install everything. Done. Now you can see that packages are installed, but depending on the state your router is in, you might need to reboot it because the kernel module that was just installed might be for different version of the kernel than what you are running right now. So if the following steps wouldn't work, try rebooting your router first. Now let's set up our WireGuard network. We go to Network Interfaces, and here we can see the list of our networks, and we can add a new one. We name it somehow, and we can see that we now have option to select protocol WireGuard. We have some other options, but today we are speaking about WireGuard. So let's create an interface. Now directly on the first screen you see that we need a private key. There is no support for generating private and public keys in Lucy as of now, so we will use CLI for that part. Now let's take a look at how we get our WireGuard key. If we log in to our router, there is now available bg command, and we can ask it to generate a key for us. And now we have our private key. What we will need on other side in our peers later on is a public key out of it. We will get that by copying the key and passing it through VG command again. And now we have private key and public key pair. We need to write those down somewhere, and we need those two for each computer that we want to connect to our WireGuard network directly. So let's paste here a key that we just generated in CLI. And listen port is the port that WireGuard will listen on. And that's the port that other peers will be connecting to. If you have public IP address, it makes sense to make this port something random but static. I'm going to use 1, 2, 3, 4, 5. Don't use this. Pick some other random port number. And we will also need to specify the IP address of the interface. In this tutorial, I will be using IPv4, but as we said previously, IPv6 might be even easier. So let's put in the IP address. And as there will be other peers on the same subnet, let's make it subnet. Now let's take a look at other options. We need to configure firewall for sure. And because we are doing site-to-site VPN, we trust the traffic, so we wouldn't do any filtering between us. So let's just put it into our LAN zone. And the last, most important step is to specify our peers. Here we will specify all the peers that are allowed to connect to us and that we will try to connect to. Let's add a peer, put in some description, and its public key that we generated in CLI as well. We can also add some pre-shared key to further improve the cryptography, but let's skip that for now. What we actually have to specify is the list of allowed IPs. These IPs will be connected with the public key, and only traffic from those IPs encrypted using this key will be allowed to enter. Everything else will be dropped. So let's put there the IP address of our peer inside the WireGuard network. And let's also put in the IP address of the subnet that is behind it. We will set it in a way that it will automatically create routes for those two networks. And now we can specify the address of the other peer. If it has public IP address, it's always a good idea to specify it here, either IP address or DNS name. In my case, I'm doing experiment only on local network, so let's go with my local IP address and port that the device is listening on. If there is a NAT between us, it is also a good idea to do some keep alive packets from time to time to keep NAT working. Specifying the IP address and port here is optional. If your other peer doesn't have public IP address, you can leave those fields empty, and it means that you are expecting the other peer to connect to you. If all your peers have public IP addresses, they can all connect to each other, and even if one of them goes down, the rest of the network works. So let's save everything. And now the last thing that we can't forget is a firewall. We need to use traffic rules to open up the port that we just specified on our router to allow other peers to connect to us. So, WireGuard, it's using just UDP, so we can disable TCP. From WAN, destination is our device, and destination port is the random port that we choose. And action is accept. Let's save everything. Let's take a look at it. In status, we have WireGuard status, and we can see our public key, our port, and we can see also our peer. We can see that there was a successful handshake and that we already exchanged some data. Now let's take a look at more details in CLI. First, let's take a look at the list of interfaces. We have a VG test interface with our specified IP address. If we take a look at the routes, we can see that we have the routes that we specified as allowed subnets as well. We have here the route for the other peer, and we also have the route for the network that is behind that peer. I can now ping the other peer to make sure that it works. And I can also ping another device that is behind that peer. In the subnet connected. So everything seems to be working. One last thing, if you want to see the status of your WireGuard connection, you can type VG command and see the screen similar to what you have available in Lucy. So that was how you set up WireGuard in OpenWRT and in TurrisOS as well. And now let's take a look if we have any questions from you. We have one question, and if you want to ask something more, you still can ask questions on Slido. First question that we have is, how would Openvpn setup compare to WireGuard 1 in site-to-site setup? That's a really nice question. Openvpn, as we saw in the previous session of Turris Academy, is mainly client-server based. And on the server, you can set it up in a way that it will push routes to all the clients. So from one side, it's easy to connect to the server, and if server has multiple sites behind it, it's easy to push different routes even for those. You have to set it up manually. We don't have it in our web UI, but the difficult part would be the other side. If you want to make the site that is on the client available from the sites that are available at the server, then you have to also allocate a static IP address to the client, make sure that Openvpn always assigns this IP address to the client, and set up the routes on the server side of the network. So the whole setup would be a little bit more complex, and we don't have really nice tools to do that. Apart from that, Openvpn would be much slower than WireGuard. I think in my tests, WireGuard was several times faster than Openvpn. So if you are doing site-to-site, you always usually care about performance. So from performance point of view, the WireGuard is the clear winner. And one additional feature that WireGuard offers us is that we don't have a single point of failure. We don't have the server that Openvpn has, and all the peers are equal. So if you need to set up not a VPN between the master branch and various small branches between headquarters and branch offices, but you need also to make it available to communicate between branch offices. If you use it WireGuard, then it might work even when you are doing maintenance in headquarters. So those are advantages that speak for WireGuard. So thank you for that question. If there is any other question, feel free to ask it. If not, recording of this session will be available on YouTube later on, so you can watch it from recording. And if you have any more questions that arise when you start implementing it, we have pretty active community at forum.turris.cz, where you can join and discuss your ideas and your problems with other Turris users and also developers, and somebody might help you. So thank you for watching, and take a look at other sessions that we already did. As the question mentioned, as question asked about OpenVPN, we already did a segment about OpenVPN. So if you haven't seen it, take a look at that, and see you next time. We will take a look at something else that might interest you. Thank you for watching. Bye.